All right, let's start off on number 2 here. So for this one, we want to first build this in vertex form. So that's always going to be y equals a times x, and then we switch the value of the x value of the vertex in there, and then we keep the y value of the vertex out there. And then I need to find a here. There's always going to be some a value out front, and we always find that by using the other point, plugging that in for x and y. Okay, and so, oh, you know what? I forgot to plug in my x, so this one's going to be 5. So now I'm going to do some PEMDAS here. So 5 minus 2 is obviously 3, so 3 squared. And so this is going to say 17 equals 9a, because 3 squared is 9. And then I'm going to add my 10 over. So 27 equals 9a, and then I'll divide by 9, so a equals 3. So now what I do is, now that I know a, I can rewrite this first step, but with my a plugged in. And that'll be 3 out front, and then I get x minus 2 squared minus 10. Now they actually want this in standard form, so I'm going to have to expand this over here. So the first thing I do is I go ahead and write x minus 2 twice, since that's what squared means. And then I need to multiply those together. X minus 2. So then we get x squared minus 2x, and then plus 4. And so the contents of this are going to replace these two parentheses with just one parentheses, which will be x squared minus 4x plus 4 once I combine the negative 2x and the negative 2x. I still have this minus 10 back there. So my next step then is to distribute this 3. So I'm going to say y equals 3x squared minus 12x plus 12. And then lastly, I just combine these numbers out back, so that'll be 3x squared minus 12x plus 2. All right, next up we want to factor these. So it's 4 terms. We use factoring by grouping. The first group I can take out b squared, which leaves me with b minus 3. The second group I can take out a negative 4. I always take out a negative when that first term in the second group is negative, and that actually switches both of these signs, so that's going to turn into b minus 3. And so then I'll write 1 parentheses for the stuff inside, and 1 parentheses for the stuff inside, which would be b minus 3. And then on this case, I see that this is the difference of perfect squares, so I can split that up again into b plus 2 and b minus 2, and b minus 3 is just going to stay the same. All right, next up here we have transformations. So I always do my left and right shift first. So for the shifts, this one will be right 1. It's right, though inside of the parentheses, the adding or subtracting is left or right. It's always the opposite of what you would think. I just remember that by saying x lies. Then the minus 15 out back is a shift down 15. And then we have, oh, that one is up or down always, the number adding or subtracting out back, and it tells the truth, so up is positive and down is negative. And then lastly, we have this 1/3 multiplying out front. And when it's a fraction there, that's going to be a vertical shrink. Anytime it's less than 1, it's a vertical shrink. Greater than 1 would be a vertical stretch. And then I don't have a negative out front, so I don't have a reflection on this one. All right, next up here, they're asking for the max or min value. And so whenever they say that, they're always talking about the vertex. However, first, I can already decide whether this is a max or min by looking at a. This one happens to be a min because a is greater than 0. A is positive. And so that always means that it's a min. I kind of visualize this as the parabola is opening up, so you can see that the vertex is the lowest point on the graph. To actually find the vertex, that's our part B, I need to use the formula x equals negative b over 2a. And so b in this case, so a, b, and c are all right there, the numbers, so I get negative 3 over 2 times 3. So this will be negative 3 over 6, which I would just reduce to negative 1/2. So that's the x value of the vertex, so now we need to plug that back in to find y. So I'll plug it in for every x, like so. Okay, we got to do PEMDAS, so I'm going to have to square this first. And so when I square fractions, I just square the top and square the bottom separately. So negative 1 squared is 1, and then 2 squared is 4. And then next up, I'm going to do my multiplication. So you can see I've put those 3's over 1. So when you multiply, remember you can just do top times top up top, bottom times bottom on bottom. So this is 3 over 1. Man, I wrote that really messy here. Let me try to write that a little better here. Okay, so negative 1/2 right there. Okay, so this will turn into negative 3 over 2, and then plus 2 over 1. And I put that one as plus 2 over 1 because now I need to do common denominator here, so I'm going to make these all a 4. And so this will turn into 3 over 4 minus 6 over 4 plus 8 over 4. And then I just add the numerators and keep the denominator the same. So 3 minus 6 is negative 3, plus 8 is 5. So that's my answer for part B. And then for part C, the domain and range. Domain is always all real numbers on these parabolas. And then for range, it's based on whether it's a max or a min. So if it's a min, then I know that that all of my y values are going to be greater than the value of the vertex, which is 5 over 4. So if you think of this as being 5 over 4 for the y value, all of the other ones are up there, so that's greater than. All right, next up, we want to sketch a graph of this function. This is actually in vertex form, so I actually think this is easier to graph. And so I can just find the vertex by switching the x value here to negative 2, and then keeping the y value at 3. So negative 2, 3 would be right there. Next up, I like to draw the axis of symmetry, which always goes right through that vertex. It's a vertical line. And then I need to find the y-intercept next, so I'm going to plug in 0 for x. That is always how we find the y-intercept. So negative 2 times 2 squared. Got to do my PEMDAS here. So then the exponent would be, turn this into 4. So then negative 8 plus 3 is negative 5. So I'm going to put a point right there at the y-intercept at negative 5. And then there's another matching point on the other side of the axis of symmetry. So I can draw my parabola. Let me try that again. That's a little bit better, like that. Next up, we're going to solve this by taking a square root. So on number 12, I can just do that right away. And so I get the square root on the left side undoes the squared, so I get x equals. And then the square root of 49 is 7, but since I created the square root, I have to put plus or minus there. So I'm going to put my answer like that. Number 14, I need to divide this 64 over first. I think I can reduce these both by 4. Yeah, so I can do that now. So then I get, nope, that's going to be 9 over 16. And now I can square root both sides. So the b squared turns into b. And then I can just square root the fraction individually. So the square root of 9 is 3. The square root of 16 is 4. But since I created that square root, I need a plus or minus in front again. Number 16, I need to add the 6 over first to isolate the k squared. And that'll be equal to 9. And then I'm going to square root both sides. And so I get k equals, and the square root of 9 is 3. But once again, I got to put that plus or minus 3 since I created that. All right, this next set, it says solve by factoring. And I kind of know I need to factor because I have an x squared and a regular x. So whenever we do this, whenever we need to factor, we need to get one side to 0. First, so I'm going to add 5x and I'm going to subtract 14 from both sides. So that means that I get x squared plus 5x minus 14 equals 0. Now we're going to factor, so I'm going to think of two numbers and multiply to negative 14 and add to 5. So that sounds like positive 7 and negative 2. So I can write this as x plus 7 times x minus 2. Now I need to solve these individually, so I set x plus 7 equal to 0, and I set x minus 2 equal to 0. On this one I'm going to add the 2 over, on this one I'm going to subtract the 7 over. So I get x equals positive 2, and I also get x equals negative 7 for this one. Number 20, same idea here. I want to get one side to 0 first, so I'm going to add this 2 over. So I get 5p squared minus 7p plus 2 equals 0. I'm going to factor it now, multiplying to 10 and adding to negative 7. However, since I have this 5p squared out front, I know I'm going to have to use my grouping technique here. So this is just going to tell me how I split up my negative 7p. So I think this is negative 5 and negative 2, so I'm going to put negative. Actually, it doesn't matter the order, but I'll go ahead and put negative. I'll do it in the same order I did here. So negative 2p and then negative 5p. And then we'll do our grouping technique. So the first group, I can just take out p, leaving me with 5p minus 2. The second group, I need to take out a negative 1, which leaves me with 5p minus 2 as well. And so this factors into p minus 1 for the outside and then 5p minus 2 for the inside. However, now that we're equal to 0, we need to set these up equal to 0 individually. So p minus 1 equals 0, 5p minus 2 equals 0. I'm going to add 1 on this, so I get p equals 1. I'm going to add 2, and then divide by 5. So p equals 2 over 5. So those are my two answers right there. All right, next up, number 22. So for this one, I'm going to get one side to 0 first. So I need to add the 9 over. I notice on this one that we have a GCF, and so I always want to take that out first. It'll make my my numbers smaller here. So I take it's going to be a 3 on this one that they can all divide by. So always watch out for that. Especially if the numbers are big. A lot of times that means we have a GCF. And so now I'm just going to factor the inside. I'm going to use the x here, multiplying to 6 and adding the negative 7. So that's going to be negative 6 and negative 1. However, once again, since I have this 2p squared number out front, I have to do my grouping technique. So I'm just going to do this as negative 6p and negative 1p. So I'll group it up. And then the first group I can take out 2p, leaving me with p minus 3. The second group, I'm going to take out a negative 1, which also leaves me with p minus 3. So I get 2p minus 1 for the outside, p minus 3 for the inside. Still equal to 0. Technically, this 3 is out here. I don't set that equal to 0 because there's no variable there. So I'm just going to set the parentheses equal to 0. And so this one, I'm going to add the 1. So 2p equals 1, and then divide by 2. So p equals 1/2. Over here, I'm going to add 3 over, and that's it. So p equals 3. All right, these ones we have a parentheses that's squared, but I need to isolate that first. So in this case, I'm going to subtract this 5 over to get rid of it. So then I have x plus 3 squared equals 9. Next up, I'm going to square root each side. So then I get x plus 3 equals, and then I have to put the plus or minus 3 here since this is the point that I created the square root. And then lastly, I'll go ahead and subtract the 3 from both sides. And this will give me x equals, and I'm going to go ahead and put this negative 3 here first, and then the plus or minus 3. Now, when we have this with two kind of integers or regular numbers here, we always want to split this up and just do it twice. So negative 3 plus 3, and then also negative 3 minus 3, taking care of that plus or minus right there. So then my answers are going to be 0 and negative 6 for x. Next up, number 26, I want to get rid of this 4 before I square root it, so I'm going to divide both sides by 4, since that's 4 is multiplying. So then I get x minus 1 squared equals 100. And now I'll square root both sides, so I get x minus 1 on this side, because the square root cancels out with the squared. And on this one, I get plus or minus 10, since I created that square root. So now we're going to add the 1 over, and so I get x equals positive 1 plus or minus 10. I keep the plus or minus in front of the 10, and now I'm going to do it twice as 1 plus 10 and then 1 minus 10. So that would mean that x equals 11 and x equals negative 9. Next up here, I need to subtract this 10 over since it's adding. So I get x minus 5 squared equals 0. And then I'm going to square root this, and I get x minus 5 equals... Technically, there's really no plus or minus 0 there. If you want to kind of get the good habit of doing the plus or minus, the square root of 0 is 0, and I'll go ahead and just leave that plus or minus there. We really don't need it though, and you're kind of going to see why here when I add the 5. So if I have 5 plus or minus 0, if I do actually split that up, 5 plus 0 is obviously 5, and 5 minus 0 is actually 5 again. So I would actually just state 5 one time, just because it's the same answer twice. I don't need to list it twice.